Okay guys, so we're going to look at the binomial theorem right now. First things first, you need to know about the Pascal's triangle. Pascal's triangle is generated the following way. So if you have, first you start with ones. Ones are the first three positions. Then any position on the outside is also a one. Now, you take these two middles and you add them together. That gives you the middle term. And so this row is 1, 2, 1. So then we go again, next row. 1 and 1 on the outside. Well, 2 and 1 gives us 3. 2 and 1 gives us 3. So 1, 3, 3, 1. And so on and so forth. We're going to do it again. Okay. 3 is 4. 3 and 3 is 6. 3 and 1 is 4. And so 1, 4, 6, 4, 1. And so on and so forth. One more time. 1, 5, 10, 10, 5, 1. And so as you can see, this triangle is generated. And why this triangle is important is because you're going to use it to do this binomial theorem thing. So if we have x plus y to the second, you guys would normally just FOIL this out, and I don't mind if you do this. You don't necessarily need the binomial theorem for this. However, how this works is you're going to use the row that is 1 bigger than this power. So this power is 2, so this is row 1, row 2, and row 3, 5, and row 6. There's always one more term than there is in the row. Okay, so we have the second power, so we're using row 3. So we're going to use 1, 2, 1. So if we use this, we're going to write out 1, 2, and 1. Now notice I'm leaving space in between them. That's important. So now to do the binomial theorem, you take the first term, you write it to the largest power. So we have x squared. Then we drop the power 1 each time, x to the 1 and x to the 0. Okay. Then we take the second term. We start with the 0 power, y to the 0, and we go up each time, y to the 1, y to the second. Okay, now to decide the signs, if they're all positive, it's all positive. If you have negatives, there's going to be swapping going on. So it might be positive, negative. There's a pattern that emerges. So 1 times x squared times y to the 0. Well, this is just 1, so that's gone. So this is x squared plus 2xy plus 1 times, that's 1, y squared. Okay, so that would be using the binomial theorem to do this. Let's do x plus y to the third this time. Okay, so we're using the fourth row because we have the third power, so we're using this row. We have 1, 3, 3, 1, 1, 3, 3, 1. We're going to start with x to the third, x to the third, x squared, x to the 1, x to the 0. And we're going to start with 0, y to the 0, y to the 1, y to the 2, y to the 3, and then this is going to be x to the third. We don't have any signs, so these are positive, plus 3x squared y, 3xy squared, plus y cubed. And so that went pretty quickly. Okay, that went a lot faster than if you folded it out twice, probably. We're going to do another one. I guess they have the fourth power now. So we're using row 5, this one. So this is x plus y to the fourth power. So we're going to write out 1, 4, 6, 4, and 1. We have x to the fourth, x to the third, x squared, x to the 1, and x to the 0, y to the 0, y to the 1, y squared, y to the third, and y to the fourth. So we take the values. This is x to the fourth plus 4x cubed y plus 6x squared y squared 4xy cubed plus y to the fourth. So that one is most definitely faster than foiling it out. I promise you that. You don't have to add any terms at the end. You do have to multiply. That's all that's going to happen. That's the only thing that's going to change. You will have to multiply sometimes, and I'm going to show you that in the next next examples. Okay. So let's do x minus 3 to the fourth. So once again, we're using that fifth row. So we have 1 I'm going to need some more space. 4, 6, 4, I'll give it a little bit more. 4, 1. Okay, so first term is x to the x, so x to the fourth. This doesn't change. X to the third, x squared, x to the 1, and x to the 0. Now the next one matters, so we're going to do negative 3 to the 0. Notice I'm putting parentheses, negative 3 to the 1, negative 3 to the second, negative 3 to the third, negative 3 to the fourth. Okay, so we've got a lot of stuff going on here. Now let's multiply this out. This is 1 times x to the fourth times 1, so this is x to the fourth. That one's easy. This is where it gets trickier. So we've got 3 x to the third, that will, or I'm sorry, 4x to the third times negative 3, well that's negative 12x to the third. We don't have a y term, so that's what that will be. This is going to be 9. 9 times 6 is 54, positive. So positive 54, x squared. Next one, this is negative 27 times 4, which I think is 108, so negative 108x. And then negative 3 to the fourth is 9 times 9, which is 81, so plus 81. And so that would be the expanded form of that. So as you can see, this binomial theorem, all that it's for really is to expand these out rather quickly, and Pascal's triangle makes this a lot quicker than having to use the combination formula, which might be more confusing to you. Okay, so we're going to finish off on the last one. We're going to need row 6 for this one, so we need that 1. So we've got 2x plus 1 to the fifth. I know I'm using row 6 because it's 1 bigger than this. 1, 5, 10, 10, 5, and 1. Okay, so let's do this. X to the, sorry, not x. So we have 2x. So this is going to be 2x to the fifth. Notice I'm using parentheses. 2x to the fourth. You should do that too. 2x to the third. 2x to the second. 2x to the first. And 2x to the 0. Okay. Then we're going to use the 1. So 1 to the 0. 1 to the 1. 1 to the 2. 1 to the 3. 1 to the 4. And 1 to the 5. Okay, let's cancel the zeros out. Those are gone. So this is 2 to the fifth. That's 32x to the fifth. Okay, so this is 16x to the fourth. So 16 times 5, I think, is 80. 16 times 5 is 80. So plus 80x to the fourth. That's 8x to the third times 1 squared is 1. So 8x to the third times that is plus 80x to the third. We've got 2x, so that's 2 times 2, that's 4, times 10, that's 40, 40x squared. 2 times 5 is 10, so plus 10x, and then plus 1. And that is the expanded form of this one. So I hope that you guys are kind of following along. Make sure you practice, guys. Practice with the last one on that page. I'm sure you can find practice in Alex. You can find it online if you need it. I'm sure they have answers posted somewhere. Just try to do this. I mean, it makes your life easier, especially if you have to expand big polynomials, and it should be kind of helpful. And it's not particularly hard. It's just remembering that you count up, you count down, you have to know the Pascal triangle, and that's about it. I hope this is helpful, guys. I hope you're doing well. Take care and goodbye.